Hello, today we're going to look at the product and quotient rules for differentiation. So we're going to look at the product rule first. If f of x is some functions u of x times v of x, so we have multiplication in here, then f prime of x is u prime of x times v of x plus v prime of x times u of x. And generally we'll get rid of the x's to make it look a little neater. And so we have f prime equals u prime v plus v prime u. So we take the derivative of one of the functions, multiply it by the other function, and then switch. The really nice thing about the product rule is that the product itself is commutative, so it doesn't matter which function you call u, which function you call v. And then the answer, u prime v plus v prime u, is again multiplication and addition, which again is commutative. So the order really doesn't matter, which is really nice. So we're going to do a couple examples. So the first one is f of x equals x squared plus 2 times 3 minus 4x. I could, if I wanted, FOIL this function out and then just differentiate term by term. Or I can use the product rule. So we're going to use the product rule. We're going to let u be the first factor, x squared plus 2, and v be the second factor, 3 minus 4x. So we differentiate them both. U prime is 2x and v prime is negative 4. Don't forget about the negative. So it's negative 4, not just 4. So then we start with u prime times v. So 2x times 3 minus 4x. And then we add to it v prime times u, so negative 4 times x squared plus 2. We distribute the 2x and the negative 4, and then we'll combine like terms. And we get f prime of x is negative 12x squared plus 6x minus 8, which is the same thing we would have got if we had, again, FOILed from the beginning and then differentiated term by term. So let's do another one. Y equals x minus 3 times 4x squared minus 2x plus 1. So again, I'm going to let u be the first factor, x minus 3, and v be the second factor. We differentiate. U prime is 1, v prime is 8x minus 2. And then we start plugging it into the formula. So the first half is u prime times v plus v prime times u. And then we're going to simplify. So I don't need the 1 times anything, so I can just get rid of those parentheses. And then I'll FOIL out the 8x minus 2 times x minus 3. Then we will combine like terms and get 12x squared minus 28x plus 7. So let's do another one. F of x equals x squared plus 1 times x cubed minus 2x. And we're going to find not only f prime of x, but f prime of 2. So again, we'll let u be the first factor, let v be the second factor. And we'll differentiate. U prime equals 2x, v prime equals 3x squared minus 2. And then we'll start plugging it in. So again, our first term is u prime times v plus v prime times u. Now at this point, I just want f prime of 2, so I can plug in 2 right here. So everywhere I see an x, I'm going to plug in a 2. So there's a whole lot of 2's in here. Just remember about order of operations. Make sure you're doing things in the order that you need to do them, right? Parentheses, exponents, multiplication, division, addition, subtraction. So here is a slightly more simplified version of it. And then the final answer, which hopefully you've tried out by now, is 66. So now we're going to go ahead and move on to the quotient rule. Quotient means division, which means fraction. So if f of x equals u over v, then f prime equals u prime v minus v prime u over v squared. So the numerator looks very much like the product rule, except there's subtraction here. The bad thing about the quotient rule is that the order very much matters. Division and subtraction, neither of those are commutative. So you really have to make sure that your numerator is the u, your denominator is the v, and that you're doing the derivative times the function in the correct order for the numerator. So So we'll do a couple examples. The first one is x minus 5 over x plus 5. U is the top, x minus 5. V is the bottom, x plus 5. When we differentiate them, we both get 1. And so I'm going to start putting it into the formula. So u prime v is 1 times x plus 5 minus v prime u, 1 times x minus 5, all over v squared, x plus 5 squared. So the denominator you don't want to square out. Remember that whenever you're simplifying things with fractions, you always want to put it into factored form. So you want to leave it as x plus 5 squared. But we can simplify the top. We get 10. So the x's cancel, you end up with 5 minus negative 5. So you get 10 and then over x plus 5 squared. And you can leave it just like that. Our next example, 3x divided by 2x squared plus 5. So again, we'll let u be the top, v be the bottom. We'll differentiate them. So u prime is 3, v prime is 4x. And then we'll start putting it into the formula. So u prime v minus v prime u all over v squared. Again, we will simplify the top. We'll distribute the 3, multiply the 4x and the 3x, and then combine like terms. You'll end up with negative 6x squared plus 15 over 2x squared plus 5 all squared. So don't forget the parentheses. You're squaring that whole binomial. And again, you do not have to actually square it out. Just leave it as 2x squared plus 5 squared. Our next example, y equals pi over x cubed. U is pi, v is x cubed. When we differentiate, remember pi is a constant. It's 3.14 something something something. So the derivative is 0. And v prime is 3 times x squared. So plugging it into the formula, I get 0 times x cubed, u prime v, minus v prime u, so minus 3x squared times pi, all over v squared, so x cubed squared. I can get rid of the 0 times x cubed, I don't need it. So I get negative 3 pi x squared divided by, remember when you're squaring something that's already raised to a power, you multiply the powers. So x cubed squared is x to the 6th. And then we're going to simplify this, because I can get rid of an x squared on the top and the bottom. So I get negative 3 pi over x to the 4th. The next one is our last example. So it's f of x equals 3x squared plus 2 over x minus 1. And again, I want to find f prime of 3. So I start with my u and my v. Again, u is the top function, v is the bottom function. Then I differentiate, so u prime is 6x, v prime is 1. And again, I'll start putting it into the formula. So I have u prime v minus v prime u all over v squared. I'm going to clean this one up first before I plug in my value. So 6x times x minus 1 minus 1 times 3x squared plus 2. Distribute, combine, collect like terms. I get 3x squared minus 6x minus 2 all over x minus 1 squared. And then when I plug in 3 times 9 is 27, 6 times 3 is 18, 3 minus 1 is 2. And then when I put it all together, I get 7 over 4. Okay, so hopefully this went well for you. If you have any questions, send me an email, let me know. Try the homework, and we'll see how it goes. So good luck.